Welcome to ESC Live. We are here at Fullabrook Down Wind Farm in beautiful North Devon. You can see the amazing views all around us with some of these fantastic wind turbines in view. We're in between Barnstable and Ilfracombe over there. We're joined by some fantastic experts today who are going to help us understand a little bit more about how the wind can generate electricity and power things in your home. We'll start with introductions. So I am Dr Alice Mills. I used to be an astrophysicist, and then I got really excited about science outreach and started wanting to tell people about science. And now I'm one of the founders and directors of the Exeter Science Centre, and we're a charity that's working to create a STEAM Discovery Centre in Exeter.
I'm Dr Natalie Whitehead, and I'm one of the founders and directors of Exeter Science Centre alongside Alice. I did a PhD in physics and an undergraduate degree in physics, and before that I was an engineer for 3 years making sustainable buildings.
I'm Mark Jones. I'm the wind farm manager here at Fullabrook. I work for ESB. Prior to working for ESB, I was a vehicle technician, and then I kind of progressed into the wind industry.
I'm Dr Adam Feldman, and I'm a lecturer at the University of Exeter. I teach the subject of renewable energy engineering. Well, let's get talking about wind energy and what is it? It's actually a form of sunshine or solar energy because the wind is made by the sunshine. What the sunshine does is that it heats up the atmosphere, the air around us, and it heats it up to different levels at different sites around the globe of the Earth. And wherever you have a high pressure and a low pressure, you get a pressure difference, and the wind blows from one site to the other. When I started in renewable energy around 20 years ago, only 2 to 3% of the United Kingdom's electricity came from wind energy. These days, last year, we made a quarter, 25% of all our electricity in the United Kingdom from wind energy.
We're going to have a little chat with Mark Jones over here.
So the tower height up into the nacelle there is 65 metres.
Right.
And also we have a blade length there of 45 metres. So each blade is 45 metres long.
And I think we're going to walk a little bit closer so you get a bit of a feel for the sound here. So it isn't actually that loud. It's quite, it's just a kind of gentle whooshing.
Each wind turbine is 3 megawatt, so 3,000 kilowatt, which gives us a total capacity of 66 megawatt across the site here.
66 megawatts, and how many homes might that be?
So that can power up to 30,000 homes.
30,000. Let's go and have a look inside.
So here we have a lift. Now the lift is there for the technicians to ascend the turbines and descend the turbines during maintenance. If the lift is out of order, they also have a ladder system which they can use to ascend and descend. Here we have the high voltage switchgear. So this is what's providing the power to the nacelle. That comes in at 33,000 volts and then climbs up this cable, the red cable there, up to the transformer upstairs where that gets turned down to 690 volt.
Is it, all these turbines are sitting on this beautiful green space, which is much nicer than a big old power station sitting taking up loads of room. What can you use the land for around it?
So the land can be utilised by usually farmers. We lease the land off them, and they carry on using all the land around it as they normally would, so they can grow crops. You can see that they've got sheep here. There's cows on other parts of it as well, so it's basically usable as it was before, apart from the footprint that you can see here now.
We've had a couple of questions. Have there been any problems with them damaging wildlife or killing birds, for example?
I've been in the industry for 12 years now, and I've never seen anything to suggest it. I can't say that it doesn't happen. There are surveys which go on. I've seen it on a number of sites where they'll come around and do surveys on maybe bats and birds and stuff like that, but I've never seen anything myself personally.
That's good. That's good to hear.
And here we have a model wind turbine going round. And even the tower is a high-tech piece of a kit. How it stays up. Remember, there's 80 tons a second going smashing into that machine and it's not falling over. So even that's a high-tech piece of kit. We have kit that controls, puts the turbine back to face the wind. This one's done by a tail, but these ones do it by having a weather vane and monitoring and electrically yawing into the wind. We have a device to turn the pitch of the blades. I'm going to alter the pitch of the blades here to make them slightly less angled, and I'm going to put that up and it's not going round. So what I'm going to do is I'll change the pitch of the blades to match the wind, and off it goes. And there's a device, the anemometer, measuring the wind on the nacelle up there, detecting the wind speed and adjusting the pitch of all those blades. And then there's all the electrical conditioning equipment that turns the power that's being made in the generator, the electricity, into a suitable form to pump into the grid to get to your school, to get to your house.
So Mr. Hayes' class, and actually Miss Gavin's class as well, wanted to know how much does each one cost, because they're very keen to put one on Pilsen Community College, apparently.
A rough rule of thumb is £1 million a megawatt. One of these machines, you're looking at £3 million.
A good calculation to do at some point would be to work out how much energy your school actually uses, because it won't need one this size. Thank you so much, Pilton and Ilfracombe, for taking part. Thank you so much to Dr Adam Feldman from the University of Exeter, to Mark Jones from ESB, and to everyone at the Exeter Science Centre team. Thank you for taking part, and goodbye!